Good afternoon, students. Hope you all are staying healthy at your home. So your next chapter is probability and its distributions. Okay. So first of all, we will study about what is probability. So if there are n exhaustive, mutually exclusive and equally likely cases. Exhaustive means all possible events. For example, if you are tossing a coin, then all possible events are either you will get a tail or a head. So there are two possible cases. So these are called exhaustive cases. Mutually exclusive mean can't happen together. This mean when you will toss a coin, either you will get a head or a tail. They can't come together. So that is mutually exclusive events. And equally likely. Equally likely means no event is preferable to the other. There is no biasness. There is total 50-50% chances if we toss a coin that we will get either a head or a tail. So they are equally likely. So now if there are n exhaustive, mutually exclusive and equally likely cases of which m are favorable to an event A. If we need to find out the probability of this event A and there are m out of n favorable cases, then the probability of happening of this A is probability of A is equal to number of favorable cases divided by the total cases, right? Then the probability of non-happening of A will be 1 minus the probability of happening of A. Fine. So the addition of these two, the complementary events will be equals to 1. Now the next definition comes out to be of conditional probability. Now what conditional probability says, for two dependent variables A and B. Dependent means they are depending upon each other. Then the symbol this P B slash A denotes the probability of occurrence of B when A has already occurred. This means we have to find the probability of occurrence of B in the environment where A has already occurred. It is known as conditional probability. That is the probability of B we are going to find, and given is that A has already occurred there. So A is given, right? So this conditional probability or this one, it's also read as probability of B given A. Fine. The next point comes of theorem of total probability. So what theorem of total probability says, if the probability of an event A happening as a result of a trial is probability of A. If the probability of an event A happening, that is the probability for this event is P of A, and the probability of mutually exclusive event B. Mutually exclusive means they can't happen together. This means either A will happen or B will happen. And the probability of happening of A is probability of A, P of A, and for B it is P of B. So the probability of either of them happening, that is to find out the probability, bracket either A will happen or B will happen, that will be equal to probability A plus B or probability A union B, that is equals to probability of A plus probability of B. Fine. So what is theorem of total probability? That the probability of either of the events happening as a result of trial is equals to the addition of their different probabilities. Right. So let's do a question based on this theorem of total probability. So your question is, find the probability of drawing an ace or a spade or both of them from a deck of cards. So now you know that in a deck of cards there is 52 cards in total, right? So how many ace are there? There are total 4 ace in a deck of card. And then how many spades are there? The spades are 13, right? So if I have to find out the probability of drawing an ace, it will be 4 divided by 52, right? Because they are total 4. So it will be 4, either of them can come, divide by 52. And there are total 13 spades. So the probability of drawing a card of spades will be 13 over 52. Then the third one is both. Both means there is an ace of spade, right? So it will be probability of drawing an ace of spade, it will be 1/52, right? So now we have to find out the probability that either an ace will come or a spade will come. This means they will not come together. We don't need this one. We have to find out the probability using this. Either the first event will happen or the second event will happen. This means we have to find out the probability that either an ace will come or a spade will come. Fine. So since the two events, that is a card being an ace and a card being of spades, are not mutually exclusive. Okay, what was mutually exclusive? That can't happen together. These two can happen together. So they are not mutually exclusive, because when a card is of ace and spade, this means both of the events come together, right? So we have to find out the probability of drawing an ace or a spade, not both. Okay, so we will using this theorem of total probability, what we will do, we will write down the probability of finding out an ace plus probability of finding out an spade minus, we don't need when they both will come together. So this is the probability when the card is of ace as well as of spade, that is 1/52, right? So we will add these two and subtract this one because we don't need this one. So this is the probability of getting an ace or a spade. Okay, so now the next your definition is of random variable. Whenever a real variable is associated with any random experiment. Okay, so for example, when you toss a coin, that is a random experiment. So there will be two values, either it will be a head or it will be a tail. So those are random variables. Either head can come or tail can come, right? So whenever a value capital X is associated with the outcome of a random experiment, then since the value of X depend upon chance, we know that whenever we do an experiment of tossing a coin, so there is a chance that either head will come or tail will come. So the value of this X will depend on chance. So this is called a random variable. It can be either head or tail. Or if you are tossing a dice, it can be any number from 1 to 6. So it will depend upon chance. Okay, so this is the definition of random variable. Okay, now if this random variable takes a finite set of values, then it is called a discrete variable. Or if it assumes an infinite number of uncountable values, then it is called a continuous variable. So there are total two types of random variable. One is discrete and the other one is continuous. Fine. So for the discrete one, I have given you example. That is, let us suppose you are tossing a dice, then the number will be number of random variable. It can vary from 1 to 6. So there is a finite set of values, right? So that will be a discrete variable. Okay. So next comes out to be the distributions, the probability distribution. There are total two types of distribution. One is discrete probability distribution and the second one is continuous. As we have studied this, there are two types of variables, discrete variable and continuous variable. So depending upon them, we are having total two types of distribution. One is discrete probability distribution and the second one is continuous probability distribution. So binomial distribution and Poisson distribution, these are the types of discrete probability distribution. Okay, these two are the types of this discrete probability distribution, and this normal distribution is the type of continuous probability distribution. You have to study about all of them. First of all, you will study what is discrete probability distribution, what is continuous probability distribution, then you will study about binomial, Poisson and normal distribution. Okay. So first of all, we will study about the discrete probability distribution. So suppose a discrete variate capital X, that is this one, the discrete random variable. So suppose a discrete variate capital X is the outcome of some experiment. We have performed an experiment and we got this discrete variate. Then the probability that X takes the values Xi is Pi. That is, let us suppose these Xi's are X1, X2, X3. If we take example of a coin, then this Xi will be X1 and X2. X1 will be getting the event when we will get a head, and X2 will be getting a tail, right? So that way he has written here that the probability that X takes the values Xi is Pi. Fine. So probability that capital X will be Xi, it is equals to Pi. Okay. And remember that this Pxi is always greater than or equal to 0. This probability is always greater than equal to 0, and sum of all probabilities of an event, that will be always 1. You have to remember this. Okay. Then the set of values Xi with their probabilities Pi constitute a discrete probability distribution that we are studying. All these values, the set of values this with their probabilities. So this will constitute a discrete probability distribution of discrete variate capital X. Now we have taken an example here. For example, the discrete probability distribution for capital X. Here is the sum of the numbers which turn on tossing a pair of dice is given by following table. You are having total 2 dice. Pair of dice mean you are having total 2 dice, right? So you are tossing them together. So when you are tossing them together, there will be a number on the first dice and a number on the second dice. So this is the sum. And we have to write down, these are Xi's. And we have to write down their probabilities, that is P of Xi's. Okay. So let us talk about this one. The sum is 2. This means when you will get a sum of 2 from a pair of dice, this means one number is on the first dice and one number is again on the second dice. So this means for this X equal to 2, the outcome will be only 1, that is 1, 1. There will be 1 on the first dice, 1 on the second dice. There is only one outcome out of 36, because when we are tossing total 2 dices, so there will be the equally likely outcomes will be total 6 into 6, 36 for 2 dice, right? So the probability of coming this sum 2 will be 1 over 36, because there is only one favorable outcome for this. Okay. So if we talk about this 3, that is the sum should be 3 on the 2 dice. Then there can be 1 on the first dice and 2 on the second dice, or 2 on the 1 dice and 1 on the second dice. So it can be 1, 2 or 2, 1. Right? So it is 1 plus 2 is 3, 2 plus 1 is 3. 1 is on the first dice, 2 is on the second dice, 2 is on the first dice, 1 is on the second dice. So there are total 2 favorable outcomes. So it will be 2 over 36. Similarly for 4, 5, 6, you can write down these outcomes. And based on these, if we draw the graph for this distribution function, that is Xi's are on this side and the distribution function having the probabilities, these Pxi's on the other side. Here I have written only about the outcomes, right? So if we draw the graph, then we will get a stair-step graph. Okay, these are the values for these Xi's, and on this side we are having the values for the corresponding probabilities. So this is the distribution function in case of the discrete variate, and this is denoted by Fx, which is what the same probability of getting X. Okay, it is what the summation of all Pxi's. Fine. So this was all about the distribution function for discrete variable, or I can say the discrete probability distribution, this one. The types we will do afterwards, these 3 types we will study. Now we will study about the continuous probability distribution. Now when a variate capital X takes every value in an interval, for example the interval is from -infinity to 1. So if the variate capital X takes every value in the interval, it will give rise to continuous distribution of X. Okay, so here instead of finding the probability that x equals to some value, we will find out the probability that x falling in a small interval. Okay, in this case the distribution function is this one, integration minus infinity to x fx dx, right? In case of this discrete probability distribution, this was your distribution function, the summation of all the probabilities, because they were discrete points, right? So here is interval, so the distribution function is integration minus infinity to x f of x dx, where this capital F of x is defined as the distribution function of continuous variate capital X, right? So these are some properties of this continuous distribution function. That is, the derivative of this function is always greater than equal to 0. This means this function is a non-decreasing function. Okay, and the value of this function at minus infinity is 0 and at infinity is 1. So in this continuous distribution, if we have to find out the probability of x lying between a to b, so it will be integration a to b f of x dx, or we can write it minus infinity to b f of x dx minus infinity to a f of x dx. That is capital F of b minus capital F of a. How? This value is similar to this one, right? So its left hand side is f of x. This x is the upper limit. Fine. So here again minus infinity to b f of x dx will be f of b. Then minus infinity to a f of x dx will be f of a. So using this distribution function, we have written this value. Okay. So this was all about the properties of continuous distribution, probability distribution. Okay. So revise till here. Then in the next lecture we will discuss about the binomial distribution, Poisson distribution and normal distribution. Thank you.